Hi everyone. Welcome to this exciting session on problem solving with linear models. Today, we're going to uncover how to interpret linear graphs, calculate slopes, identify intercepts, and use them to solve real-world problems. Let's dive right in. Our session is structured into three key parts: linear models and equations. Interpreting linear models. Using equations for predictions. By the end of this session, you'll confidently use linear equations to analyze and predict outcomes from data. Can all data sets be neatly represented on a graph? Not always. Some data sets are scattered, but they can still reveal trends. This is where the concept of the line of best fit comes in. It helps simplify complex data for better understanding and decision-making. By the end of this session, you'll learn how to identify and interpret the intercept of a linear model. Calculate the slope of a line and understand what it represents. Use the slope-intercept form to write equations for linear models. Let's start by identifying the intercept. Here's an example from a science experiment. This graph shows how the temperature of a liquid changes over time. The line of best fit simplifies the data. Can you spot the y-intercept? It's where the line crosses the y-axis. Let's look closely. The y-intercept is where the line meets the y-axis, and in this case, it's 25. This value represents the temperature of the liquid before heating began, essentially, the starting condition of our experiment. The y-intercept isn't just a number, it tells a story. For this graph, it means that at time 0, the temperature was 25 degrees Celsius. This insight is crucial for understanding initial conditions in various scenarios. Now, let's calculate the slope. Slope measures the rate of change and is calculated using the formula m equals y2 minus y1 / x2 minus x1. Using 2 points on the graph, we find that the slope is 2.5 degrees Celsius per minute. This tells us that the temperature rises by 2.5 degrees Celsius for every minute of heating. Once we have the slope and intercept, we can write the equation of the line using the slope-intercept form. Y equals mx plus b. Here, m equals 2.5 and b equals 25. So, the equation becomes y equals 2.5x plus 25. This equation represents the relationship between time and temperature for our experiment. Let's use this equation to make a prediction. What's the temperature after 15 minutes? Substitute x equals 15 into the equation. Y equals 2.5, 15, plus 25 equals 62.5. So, the predicted temperature after 15 minutes is 62.5 degrees Celsius. Try similar exercises using different values for x. Today, we learned how to identify and interpret the intercept of a line, calculate and interpret the slope, write and use equations in slope-intercept form to make predictions. This knowledge is powerful for solving real-world problems. Don't forget to practice and explore how linear models apply to everyday scenarios. Thanks for joining this brief session on linear models. If you found this helpful, give this video a thumbs up and subscribe for more engaging content. See you in the next one.